Welcome back. In previous videos, you were introduced to the common and natural logarithms. In this video, we are going to solve common and natural logarithms. We're going to solve equations that have logarithms in them. And this is going to be a similar process to solving exponential equations, but there's going to be a couple of twists to them. As a general rule, we will take the logarithms to the same base on both sides. Okay, so we'll take, usually log base 10 to both sides. We'll, what I call log both sides of the equation. And what that is generally going to do is that's going to get our x, or we'll use our properties of logarithms to get x to a point, or our unknown to a point where we can solve for it. You may also have to use the power rule of logarithms or the special properties. And once you do that, you'll be able to isolate our variable and solve. Just using the algebra skills that you've developed over the past several years. There may be situations where there are special cases. If you can write both sides as exponentials with the same base, you'll just drop the base, set the exponents equal to each other, and solve for the variable. Let's take one of these samples and see how they work. This first one, we're going to solve equations with the variable in the exponent. We want to solve 3 to the x equals 12. Well, as an exponential, we'd love to just get the same base here and then apply our laws of exponents and solve like we've done previously. We can't do that on this one. There's no way to rewrite 12 in base 3. So what we will do with something like this, we will take the logarithm of both sides. So we'll say log, common log base 10 of 3 to the x equals log 12. So as I said, we logged both sides. Well, we can apply our properties of logarithms here, and this becomes x times log 3 equals log 12. And if we divide both sides by log 3, this is the common log base 10 of 3, we get x equals log base 12, or pardon me, log 12, common log 12, over common log 3. Now this is not 12 divided by 3, it's not 4. We have to go to our calculator and input that into our calculator. So take the common log 12, divided by log 3. That's not 12 over 3, that's not 4. And we get our answer 2.262. So x equals 2.262. Here's another sample, but now this one involves e. So we want to solve e to the 0.003x equals 40. Well, since we have e, we're going to do the same thing, but instead of taking the common log like we did, we are going to now take the natural log of both sides. So the natural log of e, all raised to the 0.003x equals the natural log of 40. These are the same, whether I do that, it's probably better. The natural log of 40. Again, we can apply our properties of logarithms here, and we get 0.003x natural log of e equals natural log of 40. Well, hopefully we know that the natural log of e is 1. So that simplifies to 0.003x times 1 equals the natural log of 40. We want to solve for x, so we can divide both sides by 0.003, and we get x equals the natural log of 40 all over 0.003. So we've got calculator ready form. X equals the natural log of 40 over 0.003. So we can just go to our calculator and input now the natural log of 40 divided by 0.003, and we get 1,229.6. So that is the answer for x, 1,229.6. The next objective is to solve equations involving logarithms. This is a little bit different. Now we have a logarithm already in the equation. Okay? So to solve this, we want to transform the equation so that a single logarithm appears on one side. We'll use the product or quotient rule as needed. We might use the concept that log b of x equals the log b of y. If we have that situation, then we know that x has to equal y. And then write the equation into exponential form, and finally we will check. Okay, so solve log base 2 of x plus 5 to the third equals 4. So if we rewrote this in an exponential form, log base answer equals exponent, that must mean that 2 to the fourth equals x plus 5 all raised to the third power. Well, 2 to the fourth is 16 equals x plus 5 to the third. Then we can go ahead and cube root both sides. Cube root and the cube are inverse operations. So now we get the cube root of 16 equals x plus 5. We subtract 5 from both sides. We get negative 5 plus the cube root of 16 equals x. Well, the cube root of 16 has a perfect cube factor inside of it, which is 8. So the cube root of 8 is 2. So negative 5 plus 2 times the cube root of 2 is equal to x. And then we need to go ahead and check to see if our answer makes sense. If you look further down in the notes, you'll see our notes say, be careful when rejecting solutions. Reject any value that leads to the logarithm of a non-positive number. We don't want to take logarithms of non-positive numbers. That doesn't mean when x is non-positive. We don't eliminate x just because it's negative. We have to check it to see if it creates us taking a logarithm of a negative or a non-positive number. So that might be 0 as well. So let's check. We got to check in our original equation. So log base 2 of negative 5 plus 2 cube root of 2 plus 5 cubed, does that equal 4? Well, log base 2, negative 5 plus 5 of 2 cube root of 2 all cubed, does that equal 4? Well, let's see. 3 times log base 2 of the cube root of 16 equals 4. So we have 3 times log base 2 of 16 to the 1/3 equals 4. We can bring our 1/3 down. We have 1/3 times 3 times log base 2 of 16 equals 4. And 1/3 times 3 is 1. Log base 2 of 16 is 4. So we do indeed get 4 equals 4. And everything does check out. Here's another sample, a little bit more complicated than the previous one. Let's see how this one goes. We want to solve log of x plus log of x minus 21 equals 2. Well, doing the reverse of the product rule, we have log, our common logarithm, log base 10, we wouldn't normally write the 10, of x times x minus 21 equals 2. And then we need to write this into exponential form. So we applied the product rule. Now we're going to write in exponential form. Log base answer equals exponent. And it's not 21, it's 2. So log base answer equals exponent. So we have 10 to the second power equals x times x minus 21. 10 to the second power, well, that's 100. And then distribute our x, we get x squared minus 21x. We have an x squared, so we know we're going to have to set it equal to 0 and factor. So if we subtract 100 from both sides, we get 0 equals x squared minus 21x minus 100. And that is going to be fairly easy to factor. Factors of x squared are x and x. Factors of 100 are 25 and 4. We'll do minus 25 plus 4. Solving for x, we get x equals positive 25 and x equals negative 4. We need to make sure that we reject any value that leads to a logarithm of a non-positive number. So substituting in to our equation, we get log of negative 4 times negative 4 minus 21 equals 2. Log of negative 4 times negative 25 equals 2. Well, if we are applying our logarithms, we're trying to take log negative 4 plus log negative 25 equals 2. Well, there's no way this is going to work because we're taking logs of a non-positive number. So, no good there. And does 25 work? Well, let's try 25. Log 25, well, that's good. Plus log of 25 minus 21, well, that's going to work out for us. Log of 4 equals 2. So that's going to check out. So 25 works. Negative 4 does not because it leads to a logarithm of a non-positive number. Hopefully I said that correctly all the way through the video. And there are some samples of how to solve logarithmic equations. And we will see you in class.